some problems. That is what examples. Number 1, integral 0 to pi by 2 sin squared x into dx. By fourth theorem, it can be written as 0 to pi by 2 sin squared pi by 2 minus x into dx. But sin 90 minus x, sin pi by 2 minus x is cos x. So cos squared x. Integral 0 to pi by 2 cos squared x into dx. If you know how to integrate sin squared x, that is the answer for cos squared x also is same thing. That's what you can do it. Now next problem. 0 to pi by 2 sin cubed x dx is also equal to cos cubed x dx. How? Let us see by fourth theorem. 0 to pi by 2 sin cubed pi by 2 minus x. Sin 90 minus x is cos x. Sin cubed is what? Cos cubed. 0 to pi by 2 cos cubed x dx. One of these things we have already calculated as 2 by 3. The answer to the last problem is also 2 by 3. Now we take standard problems. 3. Integral that's what the same second problem we try to calculate. Integral 0 to pi by 2 sin cubed x into dx. Now this is written as integral 0 to pi by 2. One sin x you write here and another sin squared x is written as 1 minus cos squared x. Now put substitution. T is equal to cos x dt is equal to minus sin x into dx or minus dt is equal to sin x dx. Now come to the problem. Integral 1 minus t squared into minus dt. Now let us see the limits. When x is 0, t is what? Cos 0. Cos 0 is equal to 1. When x is pi by 2 and t is what? Cos pi by 2. Cos pi 90 is what? 0. So the problem becomes 1 to 0. So minus sign brings 1 here to the upper limit and 0 to the lower limit. Integral 0 to 1, 1 minus t squared into dt, and that is nothing but t minus t cubed by 3 open bracket 0 to 1, and that is 1 minus 1 cubed by 3 minus 0 minus 0 cubed by 3. Second bracket is completely 0. It is what? 1 minus 1 by 3. It is what? 2 by 3. So when sin cubed x dx is 2 by 3, cos cubed x dx is also 2 by 3. Next, third problem. Integral 0 to pi by 2 log tan x into dx. We call this one as I. Let I is equal to integral 0 to pi by 2 log tan x into dx. By fourth theorem, 0 to pi by 2 log tan pi by 2 minus x into dx. That is tan 90 minus x is what? Cot x. So 0 to pi by 2 log cot x into dx. You call the given problem as number 1, this problem as number 2. Say, integral 0 to pi by 2 log tan x dx, 0 to pi by 2 log cot x dx, both of them are same. 1 plus 2. So equation 1 plus equation 2 gives you 2i is equal to integral 0 to pi by 2 log tan x plus log cot x into dx, and that is nothing but integral 0 to pi by 2 log a plus log b is log ab, log tan x into cot x into dx. But tan x into cot x is what? 1. So it is what? 0 to pi by 2 log 1 into dx. So log 1 is 0, the answer is 0. So 2i is equal to 0, therefore I is equal to 0. Therefore 0 to pi by 2 log tan x dx is 0, 0 to pi by 2 log cot x dx is also 0. Next problem, that is integral 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x into dx. Now let I is equal to the problem. Let I is equal to, what do you write? Integral 0 to pi by 2. The problem is sin x minus cos x by 1 plus sin x cos x. Call this one into dx. Call this one as number 1. Now I is also equal to, by fourth theorem, 0 to pi by 2 sin pi by 2 minus x minus cos pi by 2 minus x into dx by 1 plus sin pi by 2 minus x into cos pi by 2 minus x. Now this is equal to integral 0 to pi by 2 sin 90 minus x is what? Cos x. Cos x minus cos 90 minus x is what? Sin x by 1 plus sin 90 minus x is what? Cos x, and cos 90 minus x is sin x. And this is nothing but I also. Call this one as number 2. 1 plus 2 gives you 2i. Left hand side you add, it is what? 2i is equal to 0 to pi by 2. As the denominator is same, that is what? 1 plus cos x into sin x. Numerator, you add up sin x minus cos x plus cos x minus sin x into dx. Don't see that sin x and sin x cancel, minus cos x and cos x cancel, right? Completely it is equal to 0. 2i is equal to 0, I is equal to 0. Next, fifth problem. Show that hereafter the answers will be given. Show that integral 0 to pi x sin x into dx is equal to pi. You can use by parts and work out this problem as pi, but we shall use this fourth theorem and then work out. Let I is equal to 0 to pi x sin x dx. Call this one as 1. Not necessary. So wherever x is there by fourth theorem, pi minus x. 0 to pi a minus x into this one. Pi minus x into sin pi minus x into dx. And this value is what? Integral 0 to pi minus x into sin 180 minus x is what? Sin x only. So this problem can be divided into two problems. Pi integral 0 to pi sin x, one problem, minus 0 to pi minus x sin x dx, that is nothing but given problem I. Minus I you bring here, it becomes 2i, and pi is there. Integration of sin x we shall calculate as minus cos x, open bracket 0 to pi. This is pi into minus cos pi minus plus cos 0. So this is what? Pi into 1 plus 1. Why 1? Cos 180 is minus 1 into minus is plus 1. So that is what? 2i is equal to 2 pi Therefore 2 cancels, I is equal to pi.